Hi, my name is Bennett Wong. I'm a product manager for Intelligent Automation Incorporated. We are a Maryland-based R&D company who is responsible for performing this important CIBA work. I'd like to give an overview of this project. Uh, MSPAR stands for Miniature S-band Transmit Receive Modulo for Phased Array Radar for the Navy. Founded in 1987, Intelligent Automation is a business that solves challenging science and technology problems through a research institution-inspired R&D process. With the exploratory spirit of a university research lab and the practicality of a seasoned product development company, we push the boundaries of technology and create the cutting edge every day. II develops and deploys technologies for federal agencies and corporations. Our researchers and scientists pursue innovation across a broad range of fields, and we are always looking for new challenges. We leverage technologies created through our R&D programs to create new products and bring them to the market quickly. We have developed, licensed, and sustained products for commercial and government customers. Our engineering, installation, service, and manufacturing teams support products through the full product cycle. Once delivered, our team provides full service installation and maintenance of deployed systems. Our product lines range from software analytic platforms to full service perimeter security solutions. In the area of RF, we specialize in developing advanced RF systems for military, transportation, and medical applications. Our RF technologies are used in phased array radars, portable radios, electronic warfare systems, and others. We create our systems from hardware and physical level layers to waveform processing algorithms through networking protocols. Our high-performance software-defined radios are designed for the most advanced applications, including cooperative communications and cognitive radios. The Navy is investigating an S-band transmit-receive modulo with sufficient power density for an airborne 360-degree electronically scanned array um, to make it viable as a functional surveillance asset. The current state-of-the-art transmit-receive modules lack sufficient power density to obtain the desired EIRP. Uh, New and better ways are required in order to increase the power density to a usable level. So the swap Cs that are being investigated or worked on, first of all, involve the size. The new target volume for this S-band modulo is down to 8 cubic inches. The weight is to be reduced to less than 8 ounces. The DC powered is to be operated on 28 volt DC and 115 volt three phase 400 hertz AC power. The RF power, the peak high voltage would be more than 10% duty cycle, and the cost has to be reduced for production to minimize the element cost. Other considerations include the best possible efficiency, the 3.3 gigahertz nominal center frequency with better than 350 megahertz analog bandwidth. With this project, II is designing and developing the miniature S-band transmit-receive modulo for phased array radar. It is composed of several super element modulos, SAM. These are high performance and highly modular and scalable. The SAM hosts radar waveform synthesis and processing, and IFF firmware and software, which are all developed by AI. Each SAM integrates multiple high-speed RF-capable ADCs and DACs and contain a feature-rich 64-bit processing system based on the quad-core processor on a single chip, which greatly reduces component count and overall footprint of the design. Several SAMs can be coherently integrated with a common conduction liquid-cooled enclosure framework to support a large number of antenna feeds in the phased array antenna. With the phase 2 option, we are aiming to conduct a number of MIL standard 810 tests that cover shock, vibration, and temperature, and also MIL standard 461 EMI tests. II and the PO have regular meetings to review progress on the project. These reviews include design progress and review, firmware and testing progress and review, project schedule progress and review. The last project review was in March, and the project is on schedule and according to specs. The next milestone will be in July 2021 when we will show the successful lab test with the MSPAR SAMs. The different milestones and the measure of success are shown in this slide. And right now we have already completed in March the lab test of the SAM prototype and the functional firmware and performance verification. And the next milestone would be the testing with different SAM prototypes, including with our RFNest channel emulator. With MSPAR, intelligent automation is developing the transmitter-receive prototypes to demonstrate massive phased array operation for airborne radar. This is based on cutting-edge technology and solutions for future battlefields. MSPAR would provide significant improvement in terms of RF and size that would lead to increased surveillance performance in littoral and overland detection missions and theater air mission defense capabilities. This also comes with added potentials of upgrades to legacy radar programs. For the war fighters, the value of this project consists of the following. It improves the state of the art substantially. It achieves high power density to get to desired ERRP improvement of 10 dB. It enables a 360-degree electronically scanned array surveillance asset covering both the S-band and L-band radars. It supports identification, friend or foe interrogation functions in one building block. We have proposed to Navy for the Phase 2 project, which contains major refinements to the product, making it ready for deployment into combat environment. We've been in contact with POs to make sure that we're in tune in terms of Phase 2 requirements and in general transition opportunities. We're also actively working with FST and we're participating in Navy as FST events just as this one and other ones. We've recently received the STP market research report, and we're taking steps to reach out to both Navy and other defense primes concerning transition opportunities. We're also starting to develop software-defined radios into actual products, partly based on developments from this project. The kind of SWaP-C improvements in radar performance are very much applicable to other defense and commercial RF applications in SATCOM, software-defined radio, electronic warfare, commercial 5G, and other applications. In working with STP and other industry players, we are reaching out and contacting the different program offices that may have an interest from the developments of this project, and these would include, for example, PMA 202, 231, 275, 261, 299, 276, and these include, the Navy program offices for radar, for different types of aircrafts and helicopters. And we know that there is a lot of interest also from industry primes who are involved in these projects and other projects. And we are undertaking steps to make sure that these offices are aware of our activities and of our progress. And in parallel, we're also active in commercial marketplace where we can utilize the performance and capability improvements that develop from this cutting edge project. We have developed prototypes based on MSPAR, and very soon we will have products that we can demonstrate to potential customers and partners, and these include both Navy and other primes. We are actively working on information packages for the program officers and also for the primes in order to give them updated status and information on the project achievements and advantages and how this could fit into their programs. We are working on applying these know-hows also from these projects on other defense projects so that we can apply these into maybe potentially other development projects. We'd like to thank you for spending time to understand what we've achieved with the MSPAR project and the benefits for Navy and for other branches of DoD. For more information, please contact me, Bennett Wong, at phone number area code 240-406-5493. My email is bwong@i-a-i.com. And our website is www.i-a-i.com. Thank you.